You don't really need a layer 2 to scale a blockchain, although Ethereum is trying to make you believe this. And it has been a narrative for a long while. In fact, sharding is one of the more efficient ways to scale a blockchain without building anything on top of it. It is a process when you basically split one blockchain into several more like mini blockchains that work in parallel and therefore can process transactions in parallel and make it much faster, more efficient, and basically scale. So instead of splitting the structure vertically, you split the structure horizontally, and that is sharding. And it's not a new concept. It has been used in the past for sharding databases, and multiple blockchains have used it already that are launched. So for example, Near, PolkaDot, Shardeum, but they're all proof of stake. However, there are two big proof of work blockchains which are interesting to discuss and compare. Those are Alephium and Quai Network. So they're both proof of work and they both use sharding in their architecture to scale. In this video, we're going to dive into the details, into more technical aspects of both of them, and see kind of in what aspects one may be beneficial over the other. Let's start with the core, and that is the consensus mechanisms of these blockchains. Alephium uses the consensus mechanism called proof of less work that is heavily based on proof of work, but it is aimed to enhance the energy efficiency and reduce energy usage. In proof of less work, miners can shift some of the external costs to become internal costs. So instead of spending money on electricity and spending therefore electricity and on hardware, miners spend their tokens by burning them. This may sound a little weird and like it defeats the whole purpose of proof of work being like the energy intensive mechanism that enhances security. However, Alephium claims that this does not reduce the security of the whole network. In proof of less work, the cost is the same as in proof of work, since burning coins still costs something, but the costs are composed differently, and even though you don't spend money on spending electricity, you still spend money on security and token burning. Let's kind of try to illustrate this point by creating an imaginary world where you have BTC and ALPH, that is the token of Alephium, that cost the same, and they also have about the same network of miners. In this world, you get 1.25 BTC of mining reward by spending 1 BTC in equipment and energy costs. And for Alephium, you get 1.25 ALPH of mining reward by spending 0.15 ALPH in equipment and energy costs and burning the rest of 0.85 ALPH. In the second case, the costs for the miners are the same as in the first case, however, the energy spent is vastly diminished. And this kind of balance of how much ALPH you have to burn versus how much you have to use for basically energy and hardware changes depending on the total hash rate of the network, which basically correlates with how popular the network is and how many miners there are. Now let's go to Quai Network. Its consensus is also based on the Nakamoto consensus or proof of work. However, instead of simply optimizing for the energy efficiency and energy costs and sustainability, Quai Network tries to optimize for efficiency and scalability. The key idea behind PoW is that it is the only consensus mechanism that supports infinite sharding, and basically sharding, a rule of thumb, is that the more shards you have, the higher is the TPS. So it is the only blockchain that can support as many shards as you can imagine, and the reason it can do that is because it is a perpetual consensus. So if you don't want to listen to anything technical about PoW, you can skip to, I'll put like a minute when you can skip to. But basically the idea is that it reduces the number of forks because there is instantaneous fork resolution. The way it works in regular proof of work is that imagine just like a blockchain, it's just a chain, it is a chain of blocks. And miners produce a valid block, it gets accepted, then you continue building this chain. However, if there are many miners on the network and the total hash rate is high, at some point there may be two miners that produce a valid block at the same time. So you have this singular chain of blocks, and at some point it splits like a fork, like the eating fork, into two. And you have to wait basically until somebody else comes and continues building one of those chains. And that is called the longest chain rule. And usually you have to kind of wait, and then somebody keeps working on the shard, on the part of the block that is kind of wasted later on. That is called an orphan block, or depends on the naming. There are different names for it. So basically, some work can be lost, and you also have to wait until somebody keeps producing the next block and the next block. And in proof of entropy minima, the way this kind of is solved is that instead of seeing each block as valid and treating them as equally valid, you can actually see that one of them had more work put into it than another. The way it is done is basically, instead of treating every valid block the same as valid, you measure the total weight of the block. In regular proof of work, you, as a rule of thumb, basically look if somebody produced enough zeros in their hash. So if a block hash has, let's say, 10 zeros, they consider, okay, it's good enough, the block is valid. And if somebody else produces also a block with 10 zeros, they also say, okay, good enough, we consider it is valid. However, if you actually look at further all the random or not so random numbers after these zeros that go into the hash, you can figure out how much more work was put into one block than into the other. So instead of looking only at the first part of the hash, you can look at the whole weight of the block, and that will give you an approximation, actually an actual, not an approximation, but an actual like math amount of how much one block weighs more than the other. So every miner can know without waiting until somebody builds on top of the other block, which block and which part of the blocks are heavier. So there is always one chain that is always heavier than the other. So there is no need to waste or work on the other block. You cannot really have two blocks that are both valid, because one of them will be slightly more valid. If you skipped or did not understand what I was just saying, basically think of PoW as a more efficient proof-of-work consensus that can scale and coordinate multiple shards within a network. So then the question is, what is better? And that depends on your values. If above all you value how much energy proof of work is using, you can probably switch to proof of stake and become a proof of stake maxi, but there are some caveats that you have to consider, or you should choose Alephium over Quai network in this case. However, there is a limit technically to how many shards Alephium can manage, and at the moment it only has 16 shards, and there are no plans to expand this, and if it wants to expand this, there has to be a hard fork. Quai network, on the other hand, has a different approach, and they can scale to as many shards as you need in the future, and therefore support very high throughput applications, potentially bringing more Web 2-like apps and supporting the global scale of transactions. Let's actually talk a bit deeper about the number of shards in each network. So, as I already said, Alephium has 16 shards, and they can process about 400 transactions per second. In order to scale it up, you would need a hard fork to do it, and that will require a very difficult transition. Quai network, on the other hand, uses the concept of dynamic sharding. So when the network starts, it starts with just one shard, and as it expands, it grows into more and more shards in the future, and this expands the throughput upon demand, and this demand is detected by how high the gas fees are and the number of the on-call rate. So that basically means how efficient the blockchain is. If the gas fees go too high, the network sees it and feels it, and there is an algorithmic point of just expansion of the network into more shards. There is actually an important point in how these shards are organized. So in Alephium, this is more like a traditional sharding. So these 16 shards are all on the same level, and it's all just like 16 mini blockchains working together. Quai network is slightly different in this regard. So instead of having just the shards like this horizontally, it has a hierarchical structure to it additionally. So you can think of it as like a layer 1, it has a full state of the network. It has layer 2s from it, and each layer 2 has layer 3s from it. So this is how the whole scalability is coming. And this hierarchical structure is what allows the shards to communicate between each other. And this is all very much tied with PoW. That is the process how the shards can communicate with each other in a trustless manner without any kind of bridging involved between these shards. You can also think of it as like a tree. So there is like the prime, the main chain that has a full state of the network, like a trunk of the tree. And the tree has also branches, which are the region chains or the layer 2s, so to say. And then the leaves are the zone chains where the transactions are happening, or the photosynthesis and all the like good stuff is happening in the zones or in the leaves in this case. And only the tree trunk has the full information of the full chain. And this actually has implications to how mining is done in both Alephium and Quai network. So in Alephium, miners don't choose specific shards to mine, they just come and mine all 16 shards at the same time. This is good for security because all shards share the security. However, the caveat is that you might need to increase the mining requirements for miners, for hardware, to mine effectively and receive the rewards. In Quai network, you can mine either as many shards as you want, or you can also choose to mine a specific shard or a specific slice, as they're called, of the network. So for Quai, the idea is that there is an emergent property of subnetting in this case. So let's say there is a shard that is most active in North America. Most miners of this shard are in North America, and everybody who is doing transactions is usually doing them close by and within the same country or within the same continent. So let's say everybody is doing this more or less in this shard in North America. The same thing can be happening in Asia and in Central Europe and in Northern Europe or whatever. But again, to see this happening, you need the network to grow and to become really big to really see the full power of it. So until then, I cannot really just say to you now that there is a subnetting, because it would be unfair to Alephium, which does not have subnetting. But that is the idea that is, thought about and is supposed to emerge when Quai network expands the reach and has a higher TPS per second, so that there are more shards to create this subnetting. Because these are proof-of-work chains, you have even more to talk about mining. And let's get into the hashing algorithms. It's so difficult to say hashing. I feel like I'm saying hash. The Alephium uses hashing. It's an algorithm. Yeah, Alephium uses a hashing algorithm called Blake 3. For the purposes of miners, all you need to know it is an ASICable mining algorithm. That means if you don't have specialized ASIC, specialized hardware to mine this Blake 3 hashing algorithm, you are likely going to be kind of out of luck for mining Alephium, because people who have ASICs are going to be much more efficient. So this is very beneficial for efficiency. Again, it goes hand in hand with Alephium's goal to reduce energy usage and increase energy efficiency. However, the caveat again is that ASICs are, first of all, expensive to buy if you would like to get into mining. Secondly, they become more centralized because it is a much more if you're going to buy an ASIC, you're more likely to scale and to become a farm than if you just started mining with a GPU. So going to Quai network, as I already said, it uses a GPU mineable hashing algorithm, and that is called PoW. The main idea is that it is more accessible for people all around the world. And another point towards having a GPU mineable algorithm is that it is more censorship resistant. So let's say some country decided that they did not want to have Bitcoin or some Alephium or any other ASIC mineable blockchain. That will mean that the easiest way for them to do it is to just cut out the ASIC producers from the supply chain to their country. And because there are just very few ASIC producers, this is very much easier to do, because GPUs are used all over. You cannot just cut out the GPU supply, even though there are still very few companies that do that. GPUs are used all over and not just for mining. So that is kind of the potential threat of censorship in the future, although we don't see it now. And I would say proof-of-stake networks are a bit more kind of on the eye of SEC and other regulatory agencies, and proof-of-work is more kind of resistant to this. But it is still worth to keep in mind. So this, of course, depends on your values, whatever you value more, efficiency and the scalability of your mining operations. In that case, you would want an ASICable mining algorithm that is like Alephium has. However, if you have a bunch of GPUs, or if you just want to tap into mining and try it out for the first time, you'll likely already have a GPU somewhere on hand, and you can try with Quai network. Closing point about mining for both of these networks, they're trying to innovate and make the requirements lower for miners so that more people can participate. Alephium does it by their proof of work with their proof of less work consensus. So basically, you would need a less cool ASIC in order to mine Alephium than you would need to mine Bitcoin, for example. Quai goes the other route, and they introduce the concept known as Workshares. And Workshares mean that you don't have to mine the full block to get rewarded, to get the block reward. You can just mine some of the transactions. You can even mine, I guess, one transaction, and that will be the work share of a block. And you will get rewarded of a block reward, the proportion of the block reward that you mined, if that transaction that you mined gets included into the block. And furthermore, to introduce kind of more rewards for miners, which may be important if you are a smaller scale miner, Quai Network introduces the concept of liquid mining tokens. So the idea is that you wouldn't have to take your Coinbase reward for your block reward for every block that you mine. You can basically wait and accumulate this rewards, and the longer you decide to lock them up, so to say, the higher the percentage of extra reward you can get. So it's kind of like staking within mining. And now let's talk development. There are two aspects that are important to discuss here. Firstly, that is the transaction models or the transaction model of each blockchain. And secondly, the programming languages that you have to use as a developer to do it. So transaction models, there are two main ones that exist, and that is a UTXO based model that is like Bitcoin. It is very simple, it is quite secure. You can also make it private via payment channels, and this UTXO model is kind of great for simple payments, like Bitcoin intended to be in the beginning. However, it is very difficult to build anything on top of it. So you have Bitcoin scripting or something like that, but it's very difficult to build anything on Bitcoin properly. And there is another way for a transaction model, and that is how Ethereum went on with it. That is the account-based model. And with it, you can create smart contracts and you can make much more kind of complex applications. So for Alephium, they came up with their own sUTXO model. According to Alephium developers, this sUTXO or stateful UTXO model is combining the security of Bitcoin with the flexibility of Ethereum. The tokens that are released on top of Alephium are treated as first-class citizens, so they're kind of emitted natively on Alephium chain within their sUTXO model. So this is in contrast to Ethereum, in which you have to build a token on top of the blockchain, and that is an ERC20 standard that you may have heard about. So here in Alephium, you don't need any standards, but the caveat is that it is not EVM compatible and it is quite different from anything else you've had before. So it is more difficult to develop. You would have to learn a new way of development, and this limits some of the novel use cases such as soulbound tokens and NFTs, which is just, it's still technically possible, I would assume, but it is just unusual to do. So Alephium kind of recognized the need for both the UTXO model and the account-based model and tried to combine them. And what Quai Network did, they also recognized the need for both UTXO model and account-based model. So what Quai Network did, on the other hand, instead of combining the two, they created just a dual token model. And one token is called the Chi token. It has a UTXO-based model. And for the purposes of a common human, it is the same as the UTXO model of Bitcoin. Quai token, on the other hand, has an account-based ledger behind it, which is very similar to what Ethereum has, and in fact it is also EVM compatible. So you can basically understand it all from this. It is much more friendly for developers because all you need to know is Solidity, and there are already multiple tools and everything available for it. So kind of here, Quai Network really gets a point for developer friendliness, so to say. So if Quai Network supports smart contracts and it uses EVM to execute the smart contracts, what virtual machine, that is the machine that is used to execute smart contracts, does Alephium use, since it also has the smart contracts? And they developed their own virtual machine called the ALPHred virtual machine. Yes, exactly. So the ALPHred VM is built to be MEV resistant. I cannot exactly go into depths about Alephium's virtual machine in this video. I have not researched it in all honesty enough, but I will leave a link into the article that explains ALPHred VM and how exactly it is MEV resistant. But this is a big selling point of Alephium, that they're very useful and scalable for DeFi applications specifically, because this MEV resistant or minor extractable value or minimum extractable value is important for, let's say, high frequency trading, or when you're trading meme coins, in all fairness, so that you avoid sandwich attacks and so on. To work with this virtual machine, they also developed their own programming language called Ralph, and this is actually kind of a downside, at least in my eyes, for Alephium, because if there was a way to not have another programming language, I would rather choose that way, because it is much less secure to have a novel programming language. Even Solidity at some point had a huge bug, and if it is the programming language that has this kind of bug that allows for some kind of way to manipulate or drain some smart contracts, that affects every dApp that is built with that particular version of that programming language. I don't mean to bring any FUD, of course. I'm sure the Alephium team and everybody in the security audits that did all the security audits of Ralph did their due diligence, and I'm sure it will be fine. However, just the stand of time, it just gives me peace of mind and more comfort. So which blockchain is right for you? That, of course, depends on the multiple factors that we discussed, like what hardware do you have to mine if you're a miner? Are you comfortable with developing in a new programming language like Ralph for Alephium? If yes, you're probably welcome to do so, because in the new ecosystems with more difficult programming languages, there are usually kind of the dApp developers evaluate more highly. However, Quai Network is also a very new network. It's still in testnet, and if it is important for you to test out your dApps during testnet, or if you're just a starting out Solidity developer, you would also likely go with Quai Network. And if you also only have a GPU, you don't have ASICs, and you just want to tap into mining, you would also prefer Quai Network in this case. If scalability is also of your utmost importance, you would also go with Quai, quite kind of without thinking, because of the dynamic sharding that scales to many more hundreds of TPS than you would likely need in the next few years, in all honesty. However, Alephium's 400 TPS that it supports now with 16 shards are also quite sufficient for many applications. To be honest, TPS is not supposed to be something like a selling point of a blockchain. At this point, it's supposed to be a prerequisite to launch a blockchain. We have so many blockchains that are proof of stake, for example, that have very high TPS, they have very good developer experience and good user experience, like Sui and Aptos. Like, a lot of money was put into them to make them kind of nice and cool. However, they are, like, if you look a bit deeper into them, they are going to be less decentralized than proof of work chains like Bitcoin, like Alephium, and like Quai Network. So if you care about the other characteristics other than the TPS, you can look into these two chains. Quai Network also tries to introduce another kind of differentiating aspect. This Qi token is supposed to be called the energy dollar, so to say. It is the concept of a coin that is maintaining its purchasing power over time by being connected to the price of energy, but there is no peg to anything. So this is kind of a stable coin, but not like any other stablecoin that we have at the moment on the market. Of course, I am a little bit biased, maybe not a little bit, but I work for Quai Network, full disclosure. I am in a Quai Network office right now, and I just see all the developments that have been put into it and how it tries to kind of be the last blockchain that is being built and not just another blockchain. But of course, if one blockchain succeeds, that is good for all the other blockchains as well in general. And both of these blockchains are pushing the innovation forward, especially the proof of work innovation, which is interesting to see of how these are kind of standing against all the proof of stake avalanche that is coming to us. If you like this comparison, you're likely going to like my other comparison of Quai Network and Kaspa. You can check it out here, and I'll also put some other video you can check out there. If you enjoyed this video, please subscribe to the channel. You can also follow me on Twitter and put a like to this channel because it will help it to grow up a bit more. Thank you very much for watching, and see you in the next one.